Hi, welcome everyone to the Big Data Conference Europe 2020 and my session, Azure Synapse Analytics, a data lakehouse. My name is James Serra. I am a architect under Data and AI at the Microsoft Technology Center, or MTC, in New York City. I've been in the industry quite a long time. I spend most of my days with customers talking about a modern data warehouse, and Azure Synapse Analytics has become a big part of that topic recently. The agenda for today is I'll give you an introduction to Synapse, then we'll get into what's unique about this solution, and that's the massively parallel processing part of the solution, and then we'll get right into a demo, and most of this will be on a Synapse demo. So when we look at building a modern data warehouse, traditionally we had looked at having a relational database where we have a data warehouse, and that provides you the typical operational reporting that you've had in the past and the performance, and everybody is used to that. More recently, what came out was a data lake, and that was because you had big data. This is where you have lots of data, not just the size, but the speed and the type of the data. It's semi-structured data. It would land in a data lake for exploration and experimentation, and there were usually two separate worlds. Well, Synapse Analytics tries to combine those two worlds together. And you may have heard this new term going around that's combining the data lake and data warehousing to a data lakehouse. And so think of a traditional modern data warehouse as been a number of components or products in the Microsoft set. So we have everything from Azure Data Factory to data lake storage. Databricks is in there, our traditional SQL data warehouse, MPP solution, and then Power BI. What we try to do with Synapse is and put all of this under one roof. So through Synapse Analytics, it unifies all these products together to make it very easy to use them all and not have to jump out to the various different workspaces. And you'll see how this is put together in the demo. To clear up a little confusion, what we have in GA is Synapse Analytics, and that is the former product called SQL Data Warehouse. So if you go to the Azure portal and you type in Synapse Analytics, you'll see that come up as our GA product. What is in public preview and going to be GA soon is a newer version that has a lot more features. So while Synapse Analytics focuses on the relational database, now called a SQL pool, and all those features that come from that SQL pool go into the product, and you'll see this is called a dedicated pool within the Synapse. In addition to that piece being in the public preview has a lot more other options that we'll cover in the demo. So if you go into search in Synapse Analytics, you'll see this Workspace preview, and that's the public preview version. That's going to be the focus today. When we look at the public preview version, you'll see there's a number of products that are underneath the covers, and everything is built out using a workspace. So this is sort of a landing zone or umbrella where everything that we're going to use is underneath a workspace. And you've got multiple workspaces. Usually customers will break them out by project, and within that workspace, the new product is Synapse Studio. This is a one-stop shop for all the products that we're going to talk about going forward on there. So it's that single pane of glass that you can use to interact with all these different products. One piece inside of Synapse Studio is the ingestion piece. This is where you're going to take Azure Data Factory pipelines and mapping data flows. They're not called Azure Data Factory within the product, within Synapse Studio, but they're the same code base in there. And then you can use those to move data from, say, on-prem into Synapse, into a couple of areas now under storage. One thing you can move that data into is your relational database. This is traditional SQL data warehouse where that database has a dedicated SQL pool on that. You can use regular T-SQL over that, just as in the past. You also have the ability inside of Synapse Studio to use a data lake store. And in most cases, you use Data Lake Store Gen 2. This is where you can land the data also. And what's new and what's really awesome is this serverless SQL pool. And this allows you to use regular T-SQL over this data sitting in a data lake, which used to be very cumbersome before, and you weren't able to use T-SQL. Now that feature is available in this product, and that'll be a part you'll see in the beginning of the demo. You also can land the data in Spark tables. So new is this Apache Spark pools that you can create. And within that Spark pool, you can create Spark tables. Those Spark tables can be consumed via T-SQL within this serverless pool. So I can actually shut down the Apache Spark pool after I create the table and use the serverless SQL pool to continue accessing that data and querying it. Another landing zone is the Cosmos DB that you can have an OLTP type of solution landing data in Cosmos DB, and I can access that data through the SQL serverless pool within Synapse using this feature called the Synapse link, and we'll demo that. Also within Synapse Studio is Power BI, and I can quickly and easily create a report that can do things, for example, of using a SQL serverless pool against data sitting in a data lake. So a much easier solution that's cost effective because it's serverless, meaning it's pay per query. And it allows me to query that data off the data lake. And it will seem to the end user that they're querying a relational database, but actually it's the data can all be inside of a data lake store. This allows for a new type of modern data warehouse in here. So we have the same steps as usual in a modern data warehouse, but we have many more options in there. For example, under transformation, instead of having just that dedicated Synapse pool, you can use the serverless pool. You can use a Synapse Spark. You can use the Synapse pipeline with mapping data flows in that. So a lot more options, and not only is there more flexibility, but it can result in a cheaper cost. So this is where serverless opens up this whole new world of utilizing data without having to move it to a relational database. There'll still be plenty of use cases when you want to do that, but I'm starting to see customers now find use cases that they could just keep the data in the data lake, and that'll be enough to be their presentation layer, and they can save a lot of money in the process on that. And also, as I mentioned before, I can have data that's sitting in a Spark pool and access that via this SQL, the Synapse query service. So this can be a great way to fire up a cluster, Spark cluster, do everything you need to do to create the Spark table, but then shut down that cluster and access that data using this Synapse Spark, the Synapse serverless pool. So now you can think, if we have the serverless options, what are some of the new use cases? Well, one, you can use it for basic data exploration. So I can quickly and easily look at files sitting in the data lake. And it could also be very, very inexpensive to do that, as you'll see in the first part of the demo. I can now create a logical data warehouse because I can create views over data that are sitting in these various sources, like a Spark table, a data lake, Store Gen 2, and Cosmos DB. So I don't have to always now pull the data into one spot and query off of that. And then data transformations. Now, because T-SQL is into the equation, I can use T-SQL to transform data. So maybe I copy data into a data lake using Data Factory, the piece inside of Synapse, and then I transform that data using regular T-SQL and write it back out to the data lake or right into a relational database. A quick introduction of massive parallel processing pools, or MPP. These are part of the dedicated SQL pools. And the way this works is, think of, traditionally you have this SMP solution on there where you're able to scale up. And at some point you can't scale up anymore, so you're kind of stuck. And this becomes a problem when you get into the big data and trying to query massive amounts of rows in there, and queries just taking too long in there. And you also have the problem of a query can take up all the resources and overwhelm the servers. And this is opposed to massive parallel processing, where I can scale out. So you'll see that I can create a tier, but then very easily scale that tier up. and get more query processing power. And you'll see MPP queries that are run on MPP will generally run 20 to 100 times faster than they would be under SMP. And there's also better controls for not allowing a query to go and take all the resources, because you can single out and have queries have their own sort of pieces of the pie. So the way this works is if I send a query, it will go to this control node. And this control node will take the query and create a query plan like it does in SQL Server, except it will parallelize that query plan and distribute it over on multiple compute nodes. So each of these compute nodes will be using its own storage area on there. So the idea is you can split the storage among all of these different pieces of storage areas on there, and each compute node can have part of the query running against that piece of the data. And it all runs locally in these compute nodes, and then it returns a subset of the data back to the control node where it gets smashed up and sent to the end user. So the more compute nodes I have, the more pieces are distributed over storage, and the more queries that I run in parallel. And this can allow for that 20 to 100 times faster queries on that. And all this complexity is hidden to the end user. They're not aware of all these compute nodes behind the scenes in there. They just see the control node like they do with regular SQL Server. Within the SQL pool, we have the concept called data warehouse units, and this allows you to scale up and down the performance you need on there. So instead of having to tune CPU and RAM and I/O, you can just tune using this slider and award yourself faster performance. And it's very linear. So if I have a unit of, say, 100 and I want to double my performance, I can just slide it to 200 and I'll get double that performance. A little bit about the architecture for a data warehouse. The way this works in the background is you're giving 60 distribution storage, and that's fixed. And if you start out with the lowest architecture, DDW 100, you have essentially one VM that gives you the compute power. And that VM is going to work against those 60 distributions. As you scale up, you will get more VMs, more compute. And for example, if I go to 600, I will get 6 VMs, and they will go against these 60 distributions. So one worker for 10 distributions. If I go scale all the way up, I will get 60 distributions, so 60 VMs, so 60 compute against the 60 distributions, so it's a one-to-one relationship. Now this, again, this complexity is all hidden, and that one of those matchups could change in the future, but this is the way it works. And the benefit of this too is I never have to shuffle data around. If I scale up, I don't have to have, I'm not getting additional storage that I got to reallocate all that data to. It's fixed like this no matter what DW units you are at. So quick introduction to Synapse, and now we will head over and I will start the demo. All right, as mentioned before, I go to the Azure portal, and if I type Synapse Analytics on here, you'll see that I have this Workspace preview. And if I go to that, I'm showing on here some other workspaces I previously created. So let me jump to this one, and you'll see on here the information about the workspace. Some of this will become important later, one of them being this dedicated SQL endpoint. So keep in mind everything that I'm going to do within the portal when I'm interfacing with the SQL, it can be done outside of the portal by using these SQL endpoints. So if you're used to using, say, SSMS, and you want to continue using that against the dedicated or the serverless endpoints, you just use those connection strings for it. Inside the Synapse workspace, one of the first things I will do is go to SQL pools, and here I will create a new pool. So this is very familiar to those of you who've used SQL Data Warehouse, and there's that performance level that I mentioned before that I can scale up and down, and basically that's it. When you create a pool, you'll have to have it'll also create a relational database along with it, so there's a one-to-one relationship between the two. And the other option I have underneath this workspace is to create Apache Spark pools. And this will be familiar to those of you who've used Databricks before. It's the same idea that you create a node size on here, and then you decide how many of those nodes you want. We have this because we have this auto scale option where you can have the ability to scale up and down automatically. And then under additional settings, you see we also have the ability to auto pause. So after 15 minutes, if you enable this, it'll auto pause. So this is a great cost savings that you can utilize. And once that is done, it takes just a few minutes, and you have your SQL pools and your Apache Spark pools ready to go. Now, jumping into the Synapse Studio, and you'll see if we go back to the overview, this is where you can go and jump into that. So if I click on this, I am now going to the Azure Synapse Studio, and from here I will never have to leave outside of this to do anything within a lot of the products that you'll see as we go along here. So if we look at this homepage, the first thing you will see is this ingestion piece on here. And this is typically where customers are going to start. So if I click on this, you'll see this is a copy data tool. This is the ability to move data from point A to point B. This may look very familiar to those of you who use Azure Data Factory. It's the same code base on there. And basically what you do is you go to connection, you say what's the connection information for the source, and you can see on there there's about 100 different sources. And so I would choose one of these, enter the connection information, and do that for the same for the destination, where I want to copy that data to. And what happens is that it creates a pipeline. And I can schedule that pipeline to run once, or I can run it on a scheduled basis. And what that pipeline will look like, if I go under the develop here or integrate here, you'll see the pipeline. And an example I have is this one copying SAP data. And so whatever I put in that copy data tool will show up as in this piece on here, where I have the parameters I can set for source and sync. And then I can also go and add to this activity through all these functions underneath here that you'll see. One of them could be the data flow. Now this is the mapping data flow that's also part of Data Factory built into Synapse. And if I click on this, you'll see this gives me the ability to transform data. And I have all these tasks. If I click on this, you'll see what's available to me. And basically what this is doing is taking data and cleaning it, aggregating it, and writing it back out to the Synapse. And I can write it out back out to a relational database, or I can write it to the data lake. And so it's very flexible, very driven visually on there. So a lot of customers like this because there's really no code that you have to do for this. And so it's just a matter of setting these properties. You even have things where if I can go and click on the visual, this and get the visual expression builder, where it makes it very easy to go and do those transformations on here by just basically using intelligent sense and filling in parameters. The next thing you're going to want to do is go to manage, and underneath that you'll see this linked service option on here, and here's where I can link in other resources into this Synapse Studio. One of them is going to be Data Lake Store Gen 2, and I can also link in Power BI Workspace and a number of other things on here, but those are the two most popular ones that you'll be utilizing within the workspace. So you just go in here and link them, and then you can start using them within the Synapse Studio. And if I go to data, if I link in Data Lake Store Gen 2, you will see this underneath here. And this is where we're going to I'm going to show you how to query what is in the data lake as well as other stories. So this is going to be part of the demo, where I mentioned before there was different compute options: a dedicated pool, serverless SQL pool, and Apache Spark. Each of those can go against 4 different sources, and not all of these compute yet support all of these sources. So I linked them out here which ones do not yet. So I'm going to go over some of these. during the demo. And then also I made this chart to show you that there are the ability to right click a lot of objects and generate results from them. And you can see here, I can, in some cases, preview that data. I can do a new SQL script or a new notebook. So you'll see this as a demo. So the first one I wanted to show you is going into this data lake, and you'll see that I am showing a bunch of containers here. And these containers, I've uploaded previously some data to it. And here, the first one you'll see is this Parquet folder, and which has Twitter data that are a bunch of Parquet files on it. And think of the difficulty before of querying this data. I would have to go into a product like Databricks. I'd have to create a Spark notebook. I'd have to attach to this storage. I have to write a query in Spark SQL, so different than T-SQL, and then I would generate the results in there. So it was time consuming. You couldn't use regular T-SQL, and it could be costly. Now what I can simply do is right click this, and you see this new SQL script, select top 100. I click that, and then I hit run. And the magic of this is this open row set right here. And this feature allows me to signify where I want to query, which file. And you'll see up here there's the connect information. This is saying I'm using the built-in SQL serverless pool. And then you can see within 5 seconds it returned the results on here. And I could easily see more of this data and using this chart function. So a quick and easy way to go and see this data. And not only can I query one file, but I can use wildcard characters on here. So I can easily just go like that and click run. And it went from 5 seconds. It'll be even faster now because this serverless warmed up. Once it warms up and it takes a couple seconds, everything else runs really quickly on there. So you can see the flexibility of this and how awesome this is compared to prior solutions on there. And the great thing is I'm using regular T-SQL on here. So I can also go in there and just put a where clause in there. So I can say where city equals UK. And if I run this, it's going to come back, look through all those Parquet files and show and return just the cities on there. So this is the beauty of this regular T-SQL, not a specialized version like Spark SQL. So this is what customers are really excited about. Next, I wanted to show another option. If I go under this folder with CSV files, I can simply right-click this and hit preview. And that's another even quicker way where I can go and show the results. Let me just try this again. And so you can see, okay, great, I have those results. I can also go and do that same SQL script where I can select top 100, but I can also use this new notebook and I can load the data frame. If I click on this and I choose a Spark pool and run it, what happens is this has done a lot of the work for me. I have on here automatically the Spark SQL code on here, and you can see I can use, I'm using PySpark. I have other options up here that you can see where I can choose one of these other 4 different languages, and it's done the work for me by putting out this connection information in here. And then I can now start building a notebook on this. Now this Spark pool was not warmed up, so it takes a couple of minutes, and then once it warms up, you'll see the results within a few seconds. And you also notice that there's some configuration information that I can see. This connection information, that configure information that's over here, so I can change this interactive Spark that I have, and I can utilize a different size of the Spark pool that I've created previously on there. So this is a way to prevent having all these people going in there in this interactive environment and overwhelming it. So you can choose what kind of extras, what kind of size you want to use in this environment on here. And here you can see the results. I skipped ahead. And while this took a few minutes for the first time to warm up, afterwards everything will be very quick. Now I wanted to show the workspace here. So this was the databases that I created a SQL pool, and you'll see it's created a database along with it. And I went and pre-populated all this data that's on here. And if I open up the tables in here, you will see this is traditional way of pulling data like an SSMS. And I can right-click Sales Table and go in here and do a select, and it's going to give me all the results of that relational database on that. So you can see up here, I'm showing that I'm connected to SQL pool and the particular database I'm using. I could also go to another table. Let's pick out country, and you'll see I have this new notebook, and I can click load to data frame on here. And when I right click that, I choose a pool and I can run it. You'll notice that it created the code for me to query data in a relational database and load it into a data frame in Spark. So this allows me to very easily have data, whether it's in a data lake or in a relational database, and use it within my Spark environment. And there I jumped ahead so you can see the output of that. Now, you can also, as another option, if I go under Develop and I go to Notebooks, here you'll see that I have SQL Note or Spark notebooks that were saved. And opening up one as an example, here is where I create a database, so of a Spark database on here, and then a table called fan users, and I selected from that. So behind this, so when this is executed, you're just going to create this Spark table called users, and it's just simply a file within the storage area that was defined in when you create the workspace. It will ask you for where do you want to create a primary storage area, and when it stores when it creates Spark when you create Spark tables, it'll store the data in that primary storage area. And so then if I go to data and workspace, you will see that that Spark table that I created listed here. And if I go under the oops, I created under tables, disband users here, I can then right click this and select Tab 100 and then run it. So while this table was created with Spark, I'm now going and without using the Spark cluster, using the SQL Serverless option in there to query that table, and I can get results on that without having to use Spark. The next thing to show is I will go to data and linked, and previously on the linked screen, remember before under manage link services, I also can link in a Cosmos DB database. So I have that here, and once I do that, I can then see it under my linked, and I can go open this up, and you'll see the database is there, and I can do new SQL slip top 100, and I can now go and query that database. And what I need to do is replace this key in here with that, so I won't go through it in that exercise in there, but I can now use regular T-SQL to query data sitting in a Cosmos DB database. I also mentioned that Synapse does support Delta Lake, and it does support the common data model. There's some features that are not yet available to access those in all different ways on there, but going forward, you'll be able to have full support of that. But for now, you can support it, but you can't yet support it with SQL serverless pools on there, but you can access those via Spark pools. Now I want to show you a little bit about the power of MPP technology. So there's a script here that is going to query the sales table. And if I run this, you'll see that this sales table has nearly 30 billion rows. And I'm going to query that sales table here as well as and join it with 4 other different tables on here. So, and this is a complicated select. This has a sub-select within it on there. So something like this would take minutes within an MPP solution. Now doing it with Synapse and the MPP technology, it took 2 seconds. And this is not a trick. There was an cache on here. This was uh, a full execution in just 2 seconds. So it's a pretty amazing technology. I also wanted to show Power BI integration on here. So if I go to this tab, this Power BI, I previously on the Managed Link Service tab had linked in the Power BI workspace. So now it lists what is found in that workspace. These are the data sets that has in here. I can create a new data set from the one of the sources inside of Synapse. So if I go through the start, you'll see that these are the data sources I've connected. These are the SQL pools and an on-demand pool, and I can use those to build that report. Or I can go and see the reports that have already been built out here and modify them if I wish. So opening up one of those reports, you see this is the Power BI service report builder part of that. And I can go in here and play with this and update it. And anything I change within this Power BI workspace will be reflected outside in the Power BI service against this workspace on here. So this is really a soup to nuts. Now I can go and take data and move it from an on-prem source into Synapse, into a data lake using the first feature we showed you, the copy tool wizard. I can then use T-SQL to transform that data. I can use Spark to transform that data, land it into a data lake and or land it into a relational database, and then I can go and create the Power BI reports off that. So everything can be done with this environment. You notice I never had to leave this tab on here, and that's one of the great things of having everything under one roof. As I mentioned before, you can use SSMS. So if I pull up that product on here, I had connected to those workspaces using the endpoints I showed you before, and here I'm connected to the on-demand as well as the dedicated database, and I can just simply go to that and use SSMS just like I normally would. There are some built-in monitoring tools. So if I go back to the Synapse Studio in here, you see under Monitor, I can go in here and I can look at some of the information about data factory jobs I run on there. I can see the Spark applications that I'm running right now and click on that and get more information about what those are doing. I also have this SQL request on here. So opening this up, you can see it shows me what I've run recently, and I can click on that and see what the queries were, and I can do a little bit of debugging if I needed to and check out performance issues on here. But because of the SQL endpoints are available, I can use any third-party product. So if I'm using something like Redgate and I want to continue using that product, I can do that all because of that endpoint, because it's all supports regular T-SQL. What's also helpful is some sort of jump starts that you can do within Synapse. If I go to the data tab in here, you'll see I have this browse gallery on here. And if I click on this, you will see I have all these samples that are included in here. So I have a sample data sets I can click on and use within Synapse. I have sample notebooks that I can open in there. So great things in here like examples of how to read and write data from the data lake on there. I also have sample scripts, so another great way to get kick-started on here. So you can see that there's a bunch of examples that you can use. And then pipelines. So these are templates that you can use for your pipelines on here. So if you're familiar with Data Factory and the templates, this is what that is here. So another way to get kick-started. And a lot of these templates are based on typical customer scenarios that we see. And the last thing I wanted to show is the federated query approach, that you can query data sitting in all different sample sets or different data sets that I mentioned before. So going back to the Synapse Studio, under Develop, I have a script that I created previously, and this one is called Federated Query 2. If I look at this, I'll go through this, and what I'm what I've done here in this first part is I'm querying Data Lake Store Gen 2, so you remember that open row set. And then I create a view of this. So I'm putting this metadata information over this file. And I have a Spark table that I'm querying, and I created a view for this. Then I'm also querying the Cosmos DB. So same thing, there's the query and the view that was created. And what I'm going to now do is create a query using those three views that is right here. And what this does when I run it is this is querying the Data Lake Store Gen 2, the Spark table, and the Cosmos DB table. And I'm filtering out cities that were considered banned. So the Data Lake Store Gen 2 is the tweets, and then Spark and Cosmos DB are tables that say which tweets should not be part of the output on that. And so you see after I run this, I get the results from that. And that took just 14 seconds. If I run it again, because it took a few seconds for this built-in to warm up on there, it'll run quicker on that. So 6 seconds. So think of that in just 6 seconds, I'm pulling in this data from these tables. They're not huge tables, but even if they were, it won't take that much longer. And the idea is I don't have to pull all these tables together into one source. So what I'm starting to see with customers is the use case of this federated query. Think of it as a logical data warehouse, where if performance is not on the list of higher priorities on here, I can just write these queries over data sitting where it sits. And the other great thing about this is in all three of these cases, the queries are pushed down and run where the source system is. So for example, in this Cosmos DB, if you were going to go on the Cosmos side and keep track of the queries that run against it, you would see this query come down there. So it's using the Cosmos compute for this. So not only is it utilizing data that's spread out, it's distributing the query processing for all these to the underlying systems on here, and then generating the results. In the future, we'll have others you can attach to, but for right now, we just have a handful on there, but extremely powerful. And I think we're going to start seeing a lot of customers use this for solutions and maybe not have to go and use a relational database, because the other benefit is I'm using the built-in serverless query and I'm not having to pay for a dedicated compute. I'm just paying when the query is run. All right, that's it for the demo and for my sessions. This was a Federated query. I wrote a blog about this, so you can see more details about this. And if you have any questions to follow up with me, feel free to reach out to me. My information, my email is right there, and I'm happy to take further up questions on this. And I hope you enjoyed it, and thanks for your time.